Okay, so this is question 16. We're in the Tech Active 2022 paper, and it is a slope forces. We've got an object with a mass of 12 kilos, lies on a frictionless inclined plane. Frictionless is really important. There's no friction in play. Often we refer to it, you may have come across questions that say it's smooth. That's the same thing. A rope is attached to the object at an angle of 25 degrees above the plane as shown. This diagram is only to help, it's not to scale. The force on the rope is called T newtons, prevents the object from moving. When the rope is detached, so in other words, when there's not that T newtons in play, the object moves down the plane with an acceleration of 5.6 meters per second squared. They want you to determine the magnitude of T. So we know that if T is connected, if the rope is connected and T's there, that the object does not move, it stays stationary. If T is taken away, so there's no force up the slope, that it slides down with a particular acceleration. Now I'm going to talk about my I direction being up, parallel to the plane, and perpendicular to the plane. We know forces in play. We have a reactionary force that's perpendicular to the plane, and we have our gravity force, which will be 12G going down. And where we're going, I'll just put that there so it kind of keeps us going. Don't particularly love this diagram. I found it when I first did this question a little confusing because it's got such a big box and we're not just working off a point. But we need to work this now. So I like to write down what I'm doing. So perpendicular to the plane is my J direction. And there's no movement there. The box will always be on the plane. It's not going to move off it. Parallel to the plane is my I direction. Okay. Now, let's be specific. Up the plane will be my positive I direction. Down the plane will be my negative direction. Just being really specific to what is happening. Is everybody okay with that? Now let's talk about in the I direction. I direction. What forces do we have acting in the I direction? The R force is purely in the J direction. We don't have anything happening in the J direction, so we're only looking in the I direction. In the I direction, I will have T cos 25 degrees because that's the component of my T force that is parallel to the plane, to the slope, if you want, prefer, parallel to the slope. It is also going to be positive because it's up the slope, isn't it? R is purely in the J direction. This weight force, though, has a component that is parallel to the plane. It has a component vertical to the plane, perpendicular to the plane, and parallel to the plane. Now, the way I do it may be different to how others do it, but I'm always, if I'm going in the I direction, I'm always cos. So what is my angle coming this way? Now this is where it's very hard to see there. I'm going to draw it a little bit different here. is if I have my plane there, there's my theta, and it's going straight down. Can everyone see that? What is this angle here going to be? It'll be theta and 90. Okay, so 90 plus theta would be that angle. It is going in the negative direction. Where T is pulling here, it's going 25 degrees in the positive direction. So in here, I'm going to write it as negative 90 degrees plus theta, because that's the size of that angle. Okay, so if T is in play, this is actually all equal to 0 because there is no movement. No movement. Okay. But we get a very specific, and we get told that the rope is detached. Well, that essentially tells me that T would be 0, wouldn't it be? But when the rope is detached, the acceleration is negative 5.6 meters per second squared. Okay? Because when the rope is detached, the object moves down the plane with that acceleration. So this is my forces. So my force, T is 0. All I'm going to have is 12G cos negative 90 plus theta. That's the only force in play to create our acceleration. Force is mass times acceleration. Hang on, I've got too many brackets there. There we go. So we've got force is mass times acceleration. So what we're going to have here, let's substitute in. Our mass is 12. Our acceleration is negative 0.56. 12 times 9.8 cos negative 90 plus theta. And we need to work out that angle, don't we? Solve n. Now, when you go in here and you go to solve n, let me just go here. Hang on, sorry, go down. Solve n. So I'm going to have 12 times negative 5.6 equals. Now, of course, we could have cancelled the 12s from both sides. I'm sure you can see to do it, but I am just leaving it all in. And we've got it all in there. Execute. Exit. Now, because we're looking for an angle, it actually gives us, oh, I'm in radians. I wanted this in degrees, didn't I? So let me go out and go shift setup. Degrees. I mean, you could do it in radians if you wanted to. I'm just going to go up and solve that again. In degrees. Go across and get a reasonable answer, 34.85 degrees. So from my solve n, theta equals 34.85 degrees. That is the slope. So that is the slope of my plane. Now that's a really good thing to know, but has it answered my question? My question was I had to determine T. So I now have my slope. If I go back up to here, we know that this is equal to 0 and we've got no movement. Now let's pop that in there. So we know now we're going to get T cos 25 plus 12 times 9.8 because negative 90 plus 34.85 equals 0. So I'm just going from our original statement, putting it in here. You're going to go solve n, and it will come out with T equals 74.15 newtons. And that is the tension in the rope by substituting. And that's question 16.